Okay, welcome to the RoboCore video. In this video, you won't see me, you'll only hear my voice, but we're going to take an inside look at the RoboCore controller board. Let's get started. Here it is. This is a close-up image of RoboCore. This is the controller board that you'll use for your ROBOTERRA Origin kit. This is arguably the most important piece. This is the brain of your robot. Everything that you build and program will involve this piece. So let's take a look at it here. What makes this unique? Well, like I said, it's the brain of your robot, and it's really the centerpiece of everything you build. Your robot won't be able to accept any sort of programming without the RoboCore. So it's a very essential piece of any robot you build. It's one of a kind. It was designed by the RoboTerra team engineers here. There are many controller boards on the market, different brands, and this is our own. It's built with 2 layers of resin on the top and bottom. That's the white layers that you see. They're very thin, and then copper in between. Okay, let's take a look here. If you follow the red arrow up at the top of the screen, we're going to take a look at the ports up here labeled DIO 1 through 9. You can see DIO. DIO stands for Digital Input Output. These are the ports that will be powered by the USB jack that the arrow is pointing to now. And this is where you'll connect all of your electronics, your sound sensor, light sensor, button sensor, etc. will be connected here to the DIO ports. Now take a look at the pins here. I've just highlighted one in green, one in red, and the bottom one in blue. These pins have different names. They have different electronic functions, the power, the ground, and the signal pins. Now, what's important to understand is that when you connect a wire to any of these ports, the wire contains the female end, and the pins are the male end. So these pins need to be aligned and plugged into the correct female end. So imagine that if you had rotated the female end 180 degrees, you'd have a problem because now the female power end would be connected to the male signal end and vice versa. And then the electronic wouldn't work. So this this plastic strip that the arrow is pointing to prevents that. It's called the Poka-yoke design, and it prevents the pins from connecting with the wire aligned incorrectly. So this will only allow the wire to be lined up one way, and that's so that the power, ground, and signal pins are all aligned correctly. Below DIO port 1, you see this port with 2 pins, and this one directly below that. These 2 ports are for connecting external power sources. As a quantum teacher, you really won't need to use these for the curriculum, but just so that you're informed, if you needed to attach additional power so that you're using electronics that required more power than a USB or the battery jack below it, then this is where you would connect that. Over here, this black box with the 6 holes on top, this is where the RoboCore controller board obtained its capabilities. The RoboCore uses a certain language, a certain electronic language to function, and it was through this box that language was uploaded. So this is where RoboCore was born, if you will. Now over here, this black rectangle and this one up above it, they look a little bit like centipedes. Sometimes I call them centipedes or spiders. The best way to describe these are as controller boards within the controller board. This is where RoboCore stores its information. So that language that I mentioned a second ago is stored here in these chips. They are called integrated circuit chips, or ICCs, and this is where the information that RoboCore uses to function is stored. Up here in the corner is the reset button. It will do exactly that. At any point when you press it, the program will reset. So imagine for a second that you have programmed an LED to blink 100 times. And after the 99th blink, for example, you press the reset button. Well, that program will reset and it'll begin to blink from 0 all the way up to 100 again. Even though it had already blinked 99 times. The program will reset and RoboCore will start back at 0 and follow the program to blink 100 times. All right, let's take a look at the servo ports over on the right. Here they are, all 4 of them here. You see they all have the word servo, A through D. This is where your servo motor will be attached. In order to use these ports, you need a power source to the battery jack, which is underneath this blue arrow right here. The USB jack is not sufficient. It won't provide enough power to operate a servo motor. So you need to use your battery pack, which is found in your origin kit. And once you insert the batteries, you connect it here to the black battery jack, and that will provide enough power for you to activate the servo motors after you connect them here. Furthermore, these pins are aligned differently. These pins go ground power signal, unlike the DIO ports. If you look up here by DIO 1, you'll see power ground signal versus ground power signal. Fear not, the wire that's attached to the servo motors in the origin kit are aligned appropriately. So all you need to do is just plug it in according to the Poka-Yoke design, and your pins will be aligned correctly. These 2 ports above the servos, AI1 and AI2. AI stands for analog input, and these ports are unique because they do not speak binary. In other words, what this means is that you can program something to operate along a range with these ports. So for example, say you have an LED light bulb and you want this LED light bulb to dim. So you want to start it pretty bright and then have it slowly dim all the way down until it's very, very dim and then turn off entirely. The analog input ports allow you to do that. So you'd have to program your LED to respond to different light levels, maybe 0 through 10, 0 being off and 10 being very bright. And then you'd be able to activate that LED so that it responds to different light levels. So that's what you can do with the analog inputs. Down here, these circles are really cylinders, really. These are your batteries, and they're where RoboCore stores some electrical power. So they're best described as batteries built into the RoboCore. Up here, where the red arrow is now, these are very small light bulbs, this one and this one below it. And these will illuminate orange and blue as your program is being processed. So they'll both blink, kind of similar to what it's doing right now. And that's a good thing. If these are blinking, that means that RoboCore is accepting the program that you've coded, and it's uploading that program. Down here, some more light bulbs, very small light bulbs. These will illuminate green. This one will turn on green when a power source is connected to the USB jack over here. So if you've got power into that USB, then this light bulb will turn on green. If you have both lights on, that means that your battery pack, your battery jack over here, the black one, has a power source connected to it. So the battery jack, that accepts enough power to illuminate all the ports. So both your DIO ports on top and your servo motor ports on the side will be active if you have power connected to the battery jack. The DIO ports are active with power into the USB jack, but servo motors won't be active then. And that's it, guys. That's a nutshell version of the RoboTerra RoboCore controller board. That's what you'll need to know to get your quantum course started. If you have any lingering questions or anything else you'd like to know about the RoboCore, don't hesitate to reach out and we'll get your questions answered. Good luck.